Hello all, welcome to the video lecture series for the subject compiler design. This video is going to be a continuous video. That is, the previous video I was explaining about how this direct method can be done based on the procedure nullable first and last position. Here we are going to see with one example. So the regular expression is a dot open bracket a plus b the whole closure dot a dot b dot hash. Okay, so the first thing what we are going to do here is we are going to draw a syntax tree. That is, the first thing we are going to draw a syntax tree approach where you can able to derive the first and last position of it, right? So I'm going to say that it is going to be a little tricky process. The thing is, it will always have the first and last position values which is going to be adopted over here, right? Now, so here always we are going to take the values whichever going to be performed first, that is BODMAS, that is inside a bracket, that is a plus b the whole closure, right? So I'm going to draw a syntax tree from the bottom. So I'm going to start with this. You can able to see this is the expression. So for this expression we are going to draw a syntax tree. That is the first step in conversion of RE to DFA by using a direct method, right? So I'm going to have this like I'm going to start here so that the tree is really big so that you can be able to understand clearly. So I'm going to perform the bracket value first. Here it is plus, and this is A, this is B, right? So from here the tree grows. So after this A plus B, it will have a closure, that is whole star, right? So it will has a closure value. So I'm going to have this closure over here. After this closure, you can see the value, it is starts with the previous thing, that is a dot, right? So I am little converting that dot here, and this is here. Right now I'm going to read this tree, a dot a plus b the whole star. So the first left hand side action has been performed perfectly. So you can able to see that this part is over now. Remaining part is a, b and hash, right? So it is expanding from the dot. So I'm just expanding from the dot here. Here it is a dot. So this dot represent again a. So here it is. I'll show you again. So here it is a. Again this dot expands. Again it is a b. And finally this dot expands. Again it is a hash. So all the nodes has been framed over here. So you can able to see that how exactly I constructed this particular thing. I started with a value which is inside a bracket, and later I started the same procedure by expanding the follows and first positions and last positions of it, right? I'm going to represent I'm going to say that how exactly the first position is performed first, and later I will show you how this last position has been performed. Fine. So now I am going to give numbers for all the values, all the nodes which is present here. I am going to represent this as 1. So I'll start with this pen. So 1, and this is 2, this is 3, and followed by this is 4, and this is 5, this is 6. I'm numbering these nodes because it is going to help us to exactly note down all the values of the first and follow position of this, right? First and last and follow position respectively, right? So now the first of a here, the first of a, suppose I'm going to if you recall this procedure, the first of asterisk or else a first of a or else a first of b, you remember this, always it will reflect the same value. So the first of a, the value is 2, so the first of a is equal to 2, right? And then if you see what is the last of a, both the values are same, right? The first of a is equal to 2. Sorry, I represent here as a, so it is 2, and the last of a is also 2, right? Now you can able to understand what is the first of b. The first of b is 3, and the last of b is also 3. Fine. So I am going to do in the same way with all the values, right? What is the first and what is the last? So here you can see that the first of a is equal to 1, and last of a is also 1, right? So now I am going to use different colors so that you can able to understand, because now we have a OR value here, that is plus A and B. Now if you remember what is the first position of plus, by using that you can able to remember that it is going to take a union of A and B. If you take union of A and B, that is first position is 2, here first position of B is 3, right? So I am going to represent the first position for this particular A. So here you can see this plus, the plus first position of this plus is A, we have 2, and B we have 3. So if it is plus, we are going to take union of this both first, right? So the union of both of this is 2 comma 3, that is first position. Got it? So what is the last position of this particular plus? Again, you know that last position of A union last position of B. Here what is the last position of A? That is 2. And what is last position of B? That is also 2. So here you can have 2 comma 3 as a last position. So I will represent here it is first position, and here it is last position. Here it is first position, this is last position. Okay, so this is first position and this is last position. So now I hope you understood how exactly it happens, right? Now I am going to do the same for this particular closure. As I told you already, closure will have first position of A. If you take first position of A, if you remember what I taught in the procedure, you can able to understand. What is first position of this closure? It will have first position of this plus. What is that? 2 comma 3. Here it is 2 comma 3. So this is first position of closure. What is the last position of closure? Again, it will take the last position of this plus. So that's it. So here 2 comma 3. I hope that you understood how exactly this process is happening, right? So here we always need to refer the procedure and do this. I was explaining all this procedure in the previous video. Refer that if you have any doubt on this, right? So now I am slightly getting into this dot, right? So you know very well what does the dot represents, right? Dot always represents either first or else last. If you call this for first, it will take the value. If you call this for last, it will take the value. Got it? So in this particular dot, okay, this particular dot will always have, if this value in the first is null, then it will go for the union, right? If the condition is false, then it will do the as usual process. Now I am going to find first of this dot. Okay, so left hand side I am representing this orange color to identify it as first and first position, and this purple color is for last position. Okay, so I will change here also so that you won't have any confusion. Now I hope you understood. So here it is. Now I am going to find the first position of this dot. What is first position of this dot? A. What is A's first position? 1. So I am going to represent that 1 here. Got it? So what is the last position of this dot is 2 comma 3, right? Here you can see that the last position of dot has to be mentioned over here. Yes, of course, 2 comma 3. And then I told you already, this closure have a possibility of having a null value. So what we are supposed to take? This dot, if it finds this as null, then it will take union of both of these values. That's the point. So what is that? Both of this value 2 comma 3 is already I have put here. And then if this asterisk, that is the closure, is null, it will take union of this value. What is the union of this? 1 is having there both in first and first and last. So I am going to have the same value here. Got it? So that is the only tricky thing whenever you get this closure. All the other part is simple now, right? So slightly I am moving to this dot again. Again you can see that first position, here it is first. I am going to have this same thing. So we made this is last and this is also last. First of this dot, you know very well the first value of this. We have this value already. So I am putting this value already. Got it? So now you can able to see that what is the first position for this A and what is the last position for this A. What is the first position for this A is 4. What is the last position for this A? Last position for this A, that is also 4. Right, I forgot to do this because I thought of doing that later process. So here again, what you are going to do, what is the first position of this B? Sorry, we'll do, yeah, what is the first position of the B is called as 5. What is the last position of this B? That is also 5 because it has only one value, right? So again, what is the first position of this ash? The first position is 6. What is the last position of this ash? The last position is also 6. Right? So now I am going to take it again here, this dot representation. So dot you can see here, that is here the value we have first position, dot represents here. So it takes the first position of this value. What is the last position here? Here it is 4. So you can see here the first position is also 4, last position is also 4. If you take dot last position, the same value will come. So here it is only 4. I hope you understood, right? So again, if you take this dot, so here dot B. So what is the first position of dot here? Again, we have the same thing, that is only 1. What is the last position of the dot here? The last position of this B is called as 5. So that's what I'm going to have this particular thing over here. Got it? So I hope you can say the answer for this. What is the first position of this dot? The first position of this dot is 1. What is the last position of this dot? Last position is 6 here. So I am going to represent it as 6, right? So this is how the syntax tree has to be produced. If you produce the syntax tree exactly I can say that if you produce that syntax tree exactly correct, then nothing to be done, right? So you are on the mark and it is going to be happen perfectly. Now let me take you to the next 2 levels. I'm going to draw a follow position for nodes and input and then the DFA diagram, right? Fine. So this is the next step. So I have just taken this follow position. So I have taken this regular expression which has been given at the first point I was explaining about. I have just taken this. Okay. So now I am going to name this, that is nodes, right? So I am going to name, we already named it actually, right? Previously we named it. So the same thing in syntax tree, whatever we did in syntax tree, I'm going to rename here 1, and this is 2, this is 3, and this is 4, this is 5, and this is 6. So totally we have 6 nodes. So I have taken all these 6 nodes here, right? So what is node number 1 is A, node number 2 is also A, and node number 3 is B, and node number 4, here you can see node number 4 is A, and node number 5 is B, and node number 6 is ash, right? So now I am going to represent each and every row, right? So I am going to point this each and every row perfectly. How does it exist? Sorry, I'm not using scale. So how does it exist and how exactly the values has been rectified over here, right? So let me take you to the process. Now you can see here this A, right? This A is going to have a follow position, right? Say for example, this node number 1, A dot, A dot. What is the follow for this A is A, again B, again it has a closure, right? When we have a closure, then the follow position will take to the next node also. So 1 takes this value and ends exactly before this closure value. So what is the follow position of this? I can say the follow position of this particular thing is A, that is, sorry, not A, that is 2, again comma 3. If it has a closure, that means it is null. So it will take the union, right? So it can have the previous next values also. So I am putting the position B. So this particular one have a follow position of A, B, that is 2, 3. If you have a closure here, then it will depends on the next node when because it can be a null. So it will depend on the next node also. The number follow position is given. So I am going to take here the input is the node is 2 and the input is A again. Here you can see the node 2 node. So I told you already, if it has the asterisk, that is closure, it will depend. So initially it starts with 2 and it goes to the 3. We have a closure, so it will depends on the next node also. So 3, right? So 3 in the sense it will have the input as B. So you can see here. So what are all the follow position? It has 2, 3. Why? Because it has a closure values A plus B the whole star. So I will take this 2, 3. If we have a closure, it will depend the next node also. Then it is 4. Now you will understand the same process because there is no closure here. You can see here what is the follow position of this 4 is 5, because after 4 you have the next node as B. So that is the value. The A will take and it will reach to B. So what is the node we have? That is 5. Got it? So this is the follow position of node number 4. What is the follow position of node number 5? That is called as ash. That is called as 6. So here it is. So what is the follow position of 6? After 6, that is ash, we have nothing. So after 6, you can see we have nothing. So what I'm going to do here, it is infinity. Sorry, it is not infinity. There is null. It is not going to travel anywhere. Now I'm going to draw for this particular table. I'm going to draw a DFA. Now you need to look very carefully. Why? Because this particular DFA has to be constructed only by taking the unions of this, only by having the values in this, right? So the first node, I'm going to take it as 1. It is a set of node. Say for example, so I'm going to draw this so little bigger so that you can have this particular point. So node A takes an input and it is reaching the follow position 2, 3 and 4. Right? So now I'm going to take this 2, 3 and 4 as a new set. So 1 is taking, this node number 1 is taking A, right? And it is reaching the set called, follow position called 2, 3 and 4. So this is a new node. This is a set of node. Got it? So now I hope you can able to follow that how exactly this A is travels. So let me take you to the next position. See here, 2. So 2 is in this particular set. Okay. 2 is taking an input called A and it is reaching the follow position called 2, 3 and 4. Okay. So now we need to have where is the other A which is present in this input. First thing, this A is completed. Second thing, we need to see the union of this particular thing, because the other A, one more A, it is there in the node number 4. Okay. Why? Because we are drawing a DFA. So there should not be the same input when it travels from one node to another node, then it is not a DFA. So we need to take an union here. So you can see here, see exactly I am in this position. I am solving this 2. Node 2 is here and it is taking A to reach 2, 3 and 4. So if I put itself, because A is taking itself and reaching here, again this node will not produce A and it will throw that to output. So why? Because 4 is already here. So I'm going to take this 4 also. Got it? So in this 4, what is the follow position? 5. So we got a new set now. Got it? So now what I'm drawing here, it is, it takes A, that is 2 is taking A and also 4 is also taking A to reach the value and the node called 5. So I'm going to union both of this follow position. What is the union? 2, 3, 4 and 5. That is a new set. That is the union of this. Got it? So I'm going to draw this 2, 3, 4 and 5. So this is one more set which is taking A and reach. So here 2 and 4 has been solved, correct? So now this is the process. Now I am going to move on to this particular node called 3. Okay. So 3 is taking B and it is reaching the follow position called 2, 3 and 4. Right. So here you can see here the another node is called as 5, that is also taking B and it is reaching 6. Okay. So now this 3 is a different set and this 5 is in a different set. So there is no problem for us to take B here and also here. Why? Because I told you already, DFA will never take two inputs from a particular node to another node. So I am going to have this B over here. The 3 is taking B. This 3 is taking B and it is reaching where? 2, 3 and 4. So 3 is taking B and is reaching 2, 3 and 4. Okay, now I will solve this particular question. Again 5. Where is 5 here? You can able to see 2, 3, 4, 5 here. 5 is taking B and it is reaching 6. So 6 is not here, right? So we need to construct this particular thing. So we have already have this particular process. 5 is taking B and it is reaching 6. Where is B here? One more value here it is. So we need to take union between these two, right? So I am drawing the one more set. Sorry. So I am drawing the one more set here. That is, here it is. It is taking B and it is reaching 2, 3, 4 and 6. So I have union only these two because we have two B's here, 3 as well as 5. So 2, 3, 4 and then 6. Now you can see how exactly it happens. Got it? So 2, 3, 4, 5 is taking B and is reaching 6 here. The 6 is also here. And 3 can also take B, reach it can 6 here. So whichever the possible way, we can able to do that. Okay. So now let me take you to the next part of it so that you will find how exactly this procedure works. Okay. Now we are reaching to this 4. 4 is taking A and is reaching 5. Where is 4 here? You can see here 4. 4 is taking A and it is reaching 5. So this 4 is already reaching 5 here. We have solved this already. Got it? And 5 is taking B and it is reaching 6. So we need to look for all the possibilities. What is the next possibility you have? Here it is. See 2, 3, 4, 5. So 2, 3, 4, 5 is this 2, 3, 4, 5 is taking A and it is reaching itself. That is 4 is taking A and it is reaching 5. So I can put A here. Likewise, here you can see it is taking B. Now you can see here 2, 3, 4, 6, the possibilities. So you can see 2, 3, 4, 6, which is taking A and reaching the destination. So 2 is taking A and reaching this 2, 3, 4. 4 is taking A and is reaching that 5 node. So we can able to construct this way. That is 2, 3 and 6, which is also taking A to reach this particular destination called 2, 3, 4 and 5. Okay, so we have derived all the possibilities. We are going to check again, that is whether 2, 3, 4, 6 can take B, because A has been already taken, can take B to reach any other node. Yes, we are searching here. So 2, 3, 4 and 6, which is taking B. So 2 is not taking B and 3 is taking B. Yes, it is reaching 2, 3, 4. Yes, we can derive over here. So 2, 3, 4, 6 here also. We need to check for all the possibilities and it is reaching 2, 3, 4. See here we need to take all the possibilities and we need to draw a DFA for this particular point. Now you can check the diagram. See here. So 2, 3, 4, it is throwing A to the next node and it is taking B itself. And 2, 3, 4, 5, it is throwing B to next node and it is getting A and by itself it is getting A, right? And 2, 3, 4, 6, it is throwing B and it is throwing A to the another node. So we are going to look for all the possibilities, all the possible way where we can do. Now see here, this is the first node which is throwing only A to the another node. So it doesn't have B which is thrown from one node to another node. So I am putting that as a null state, right? This state, it is called as null state. So B never travel from A. So I need to put that. And also this null state will not take A and B. Got it? So this is how this particular direct method works. So most of the possible procedure, if you see that, so you can able to understand how exactly it works.